Alô? Alô? Vamos chegando, gente. Por favor. O pointer tá aqui, tá tudo funcionando.
I almost didn't make it. How are you guys?
Hello. Good evening, everyone. Hello, everybody. Okay, so let's start our activities that night. So first, we'll have a movie here from institutional movie, and then after that, we'll start our lectures, and I will introduce you the speakers for tonight. And I hope we'll have a very exciting and very interesting topics for discussion today. Thanks so much.
Todo mundo sabe o que é tradição, mas ninguém sabe quando ela nasce. Harvard levou 140 anos para virar universidade, mas os tempos mudaram. Hoje, tradicional é procurar na internet. Há 20 anos, era na enciclopédia. A tradição agora é usar um WhatsApp. 6 anos atrás, era o SMS, lembra? Hoje, para construir um legado, você não olha para trás, e sim para frente. Porque tradição é mirar as próximas revoluções da medicina. É ter professores que são referência em todo o Brasil. É usar tecnologia para inovar no método pedagógico. É ter parcerias com instituições de ponta, como Stanford e Emory. Tradição é formar agora os profissionais da medicina do futuro. Medicina Fazer, nota 5 no MEC. Fazer, nasce uma nova tradição.
Thanks again for coming. And thanks, Dr. Ricardo Guimarães. I'm very happy you are here supporting all the activities. Thank you so much. And you are very busy, so thank you for being here. And thank you to you, all students and all people interested in the topics we'll be discussing tonight. And the first topic we'll be talking about arbovirus epidemiology, prevention, and control. And we have two speakers for this specific topic. So I would like to invite Dr. Michael Maurer from the University of Miami. He'll be talking about, does immunity after Zika virus infection cross-protect against dengue? That's a good question, huh? Hopefully we'll have answers. So thank you so much. Come on, please welcome Dr. Michael Maurer.
Good evening, everyone. Oh, can you hear me? I kind of like to hold the microphone, so. All right, let me make sure I can move this along. Okay, perfect. Hi, everybody. I'm Dr. Mikey Maurer, as Jose Antonio said. I'm a general pediatrician at the University of Miami, and I'm here this year forming a new collaboration with FASE as an institution. I actually came to Belo the last 2 years working with FASE, and I was actually a pediatric resident at Stanford. And so Dr. Lebode and I worked together the last couple of years. And so you'll hear a little bit about that. But thank you all for having me here, and let's go ahead and get started. So we're going to talk tonight about some arboviruses. And so the question is actually not about really, does Zika infection confer immunity for future dengue infections, but really it was, where did all the dengue go? Because that's what we've seen the last couple of years. So we're going to take a much closer look at the actual immunologic mechanisms at play when it comes to Zika and dengue and how those sort of interact with each other. My only disclosures are I have no financial disclosures. However, I am definitely not an infectious disease expert. I'm also not an immunologist. I am a general pediatrician. So I'm not an expert in this field, but I spent a lot of time learning about this over the last 2 to 3 years since I was doing this project with Dr. Libot and Jose Antonio and the rest of the team here at FASE. Also, most of what I'm going to share with you tonight is not my original research, but it's more a compilation of a lot of research that's been done by experts in the field. And so it's very important that we take that into consideration as well. Our objectives for tonight are to understand the background of both dengue and Zika infections throughout history, the world, and kind of more in Brazil. We're going to learn the immunologic responses to dengue and Zika infections, and we're going to discuss possible cross-protective mechanisms between dengue and Zika virus infection. So hopefully you guys will come away with a little bit more knowledge regarding those topics. But I want to take a little bit of a walk down memory lane. So let's go all the way back to 1947. Do you guys know what happened in 1947? There were a few things going on in the world, but particularly in Uganda at that time. No? Good, not many people know, but that is where Zika was first discovered in a rhesus monkey. And so that's where they finally realized that there was this new virus out there. The Zika virus is the name that they gave it. And then in 1954, I believe it's on the next slide. In 1952, the first human cases were also discovered in Uganda at that time. For the next 40, 50 years, there weren't that many bad human cases of Zika virus and Zika disease, actually, until down here in 2007, we ended up in the Yap Islands, and over 70% of the population actually became clinically ill with Zika. They had really a mild febrile illness at that time with some rash. And since then, there were a couple other smaller outbreaks, some in the Pacific Islands, French Polynesia in 2013, 2014. And then what happened? 2015 happened. So in February 2015, up in the northeast of Brazil, they found about 7,000 cases of this very mild febrile illness with a skin reaction, but they didn't test it at that time for Zika infection. But we later realized that this likely was a large Zika outbreak that had started in Brazil, as many of you are very familiar with. But it actually became very well known because of what we're seeing right here. So many of these arboviruses are, as Dr. Labode mentioned yesterday, neurotropic. And so they do go after the brain. And what we actually found is even though adults didn't really get sick of it, many of you wouldn't have gotten sick with the Zika virus at all. But if you had been pregnant at that time, your fetus might have been affected, and they really noticed microcephaly. And so it came into this large mainstream at that time, which was very exciting for virologists and for people wanting to learn a little bit more about this. But it was quite devastating for the families that were affected by this. And not only did it cause the microcephaly in our fetuses and our infants, but it also caused a complication called Guillain-Barré syndrome, which is an ascending paralysis. And so those were two of the big neurologic complications that brought Zika virus into this light with such widespread disease throughout Brazil. But otherwise, it's a pretty mild illness for most of us. And so that's what brought me to Brazil in the first place, was to study Zika virus sort of at the height of the infection. So Dr. Jose Antonio and Dr. Labode had put together this project, and I came down to roll it out. And so some of these faces are in the audience this evening with many of our FASE medical students. And so what did we do? We were at Hospital Odilon Barons, and we did a febrile illness study in 2017. And so we actually were just looking in the emergency department of, we were told it was so busy, there were going to be so many cases. And we got 22 kids that came in with fevers that we were worried about potential arboviral infection. And what actually ended up happening is that none of these patients were positive for Zika, dengue, or chikungunya virus by PCR is how we tested them. But not only that, we later, with the lab at UFMG, we actually ran serologies. And so none of them had IgM either. And so that more confirmed that none of these patients really had arboviral infection. They had some other viral illness. But a few of them did have IgG for dengue. I think 3 or 4 did. But anecdotally, across the entire country, everyone was just seeing these large number decreases in both dengue and Zika infections in 2017. So the new question became, and mostly because dengue was so much more prevalent in the first place, where did all of the dengue go? And we'll look at that in the next couple of slides. So what happened in 2017? So this is a nice little graph about dengue over the course of the last, almost 40 years at this point. 1980 was 40 years ago. And so if you notice, what we really see is that our reporting skills got a whole lot better over the last few years, because dengue has been around in Brazil for a really, really long time. but we really increased our reporting. But you can see this sort of cyclic variation in dengue infections, but the overall total cases were increasing to the point where we get here in the 2010s, and around 2015-16 is really the height of our total numbers of dengue infections at that time. And so if you look at it, in 2015, 2016 combined, we had over 3 million suspected dengue infections during those 2 years, with at least 800,000 confirmed by laboratory testing. And then the next 2 years, it significantly fell off. So not quite 300,000 suspected cases with way less confirmed cases, and then a bit more confirmed cases last year. But I think that might be really, I mean, these numbers are getting pretty close, which shows that our testing might be getting a little bit better from a diagnostic and really identifying patients that are more likely to have this disease. But you can kind of see there's always a drop off after some of the bigger outbreaks. But this outbreak was actually, this drop off was way larger. It's like an 80% reduction or something in total number of cases. And so this is another sort of, this shows between 2015 and 2016, 2017. So I want you to pay attention mostly to the black line. So the black line is actually 2016. If you notice here in like the epidemiologic week of 2024, 25 is where we really see the sort of end of the dengue outbreak. And then all of 2017, this darker gray line has absolutely nothing there. And then if you sort of overlay that on top of the Zika line, really here at this like this epidemiologic week 25 again is where all of the Zika disappears, and after that we really don't see any other cases. There were a few suspected and confirmed cases in 2017, and anecdotally I'm sure what you guys are all seeing now is that Zika has nearly disappeared from Brazil at this point, and nobody has that. So we're not totally sure exactly why, but I'm going to show you a little bit of what I think happened. So where did all of this dengue go? So if you look at it, the raw numbers of Zika infections were only in sort of the hundreds of thousands compared to 3 million dengue infections. And so even though Zika had these really big problems with microcephaly and with Guillain-Barré syndrome as complications, dengue really was still causing a lot more morbidity and definitely mortality when it came to dengue hemorrhagic fever as well. So we really wanted to know, where did dengue go? So we're going to talk about the immunologic mechanisms, and a really important question is this idea of, since Zika happened at the same time as that big dengue outbreak, does a Zika infection actually confer immunity to future dengue infections, and did it cause such a sharp decrease in dengue infection the last couple of years here in Brazil? So the first type of mechanism we're going to talk about, and I'm going to talk mostly these next couple of slides about dengue in particular and what happens after you get a dengue infection, and then we'll tie that into what happens after you get a Zika infection as well. So I want to talk very basically about a classical approach to immunology when it comes to these viral infections. And so I want you to think about getting a vaccine, or maybe if you had chicken pox as a kid or a varicella infection. And so what happens when we give vaccines? We basically are trying to create some sort of immune response that creates these antibodies that are going to live in our bloodstream. And whenever we're exposed to this particular antigen again, being that we would mount this immune response that keeps us from getting sick from these infections. So that's the principle behind vaccines. And it's also one of the thoughts of what can happen with dengue infection. So you get sick with dengue, you create these antibodies to it after your whatever your illness might be, and then you are protected in the future. Well, dengue is not that easy. So dengue has 4 primary serotypes, and each one of these has multiple serotypes. And so what does that do? It creates a lot of immunologic mystery as far as exactly what happens in our bodies after a response and what could potentially protect us against it. But not only that, it creates a lot of misery for the people that want to learn about it, because it's so confusing, and you really just, it's quite complicated to fully understand exactly what happens, because there are so many different versions of dengue out there for us to try to combat. This is also a big reason why it's been so difficult to create a vaccine against dengue. And so I think there is one right now in clinical trials, but overall, we just haven't been super successful at creating a vaccine. And as you saw earlier, the serotypes kind of circulate through communities. And so anecdotally, they're worried that dengue is sort of back on the uprise right now. Although we saw some numbers the other day that show it's about the same as it was last year, but they have already seen a few deaths related to dengue fever. So this is kind of why dengue is super dangerous. And so this is the whole mechanism that occurs when it comes to dengue hemorrhagic fever. So the first time you get dengue, so how many of you have had dengue in this room or thought you had dengue? Did you guys get super, super sick or just kind of sick? Super, super sick. Yeah. So the first time people get dengue, they might not get all that ill, actually. And so what actually happens is that you create what are called subneutralizing antibodies. And so that's going to be this little heterotypic antibody. So say you got dengue 1, some subtype of dengue 1, and you had these little antibodies that were subneutralizing, swimming around in your bloodstream. And then dengue 2 came around and decided that it wanted to try to infect you. There's this crazy immunologic mechanism where it binds to this like FC gamma receptor, and then it actually increases the viremia. So it increases your total viral load of this new dengue 2 infection. And that's actually what causes the dengue hemorrhagic fever and why people get really, really sick. So it's not always the primary dengue infection that causes people to get super sick. It's more this secondary infection. And so what do we call this? We call this antibody dependent enhancement. And so this is a really important topic when it comes to looking at the reactions between dengue and Zika virus, which we'll talk about in a few minutes. So the second reason that people might become immune to dengue and maybe saw a big decrease in the dengue incidence the last couple of years is the secondary mechanism. So people get infected with dengue once, they create these subneutralizing antibodies, they get it again, they maybe get a lot sicker, but if they live and they happen to not die because of their second dengue infection, then they actually have really good immunity against dengue. And so hopefully in the future, they're actually going to be able to fight it off. So they aren't sure exactly why this happens, but there is this thought that this helps us to get to that level of really being immune to multiple of the subtypes and serotypes of dengue infection. And so this is also really important when it comes to looking at Zika as well. So when it comes to Zika and when it comes to dengue together, they are a match made in structural proteins, not necessarily heaven. And so what are the main proteins that we look at? So what we found is that about up to 50% of the envelope proteins on Zika and dengue actually have pretty similar homology. And so that basically means that your body can create a similar immune response to both of these. What they found is that this ED3, this envelope protein 3, demonstrated to be the most neutralizing, but actually the least cross-reactive out of the 3. So the envelope 1 and 2 were most similar and had a higher cross-reactivity and thus higher immunity following one of the 2 infections. But the third one is actually the most neutralizing. So if you were to create antibodies to this ED3 protein, then in the future, when you are exposed to these particular viruses, then you'd be able to be immune to those. And so that's one thing that we know. And then other important proteins that they've demonstrated when it comes to similarity between Zika and dengue are the pre-membrane protein, as well as one that's called the non-structural protein. And the non-structural protein is actually super unique because they think that this helps a lot with the cytokine release. And so if you can actually create good antibodies to this NS1 protein, then maybe you can sort of mitigate some of the symptoms that would lead you to having something like the hemorrhagic fever. But then what they actually saw with these 2 different proteins is that the antibodies to these proteins really showed up more in convalescent infection, so not really in that acute phase. So it's still unclear the true role that these play. So what does this all mean? It seems kind of confusing, right? So Zika and dengue kind of seem alike because they're both flaviviruses and they have some of these structural proteins. Well, basically, when it comes down to all of this stuff, we're looking at Zika and dengue together can have this antibody-dependent, this antibody-dependent enhancement with each other. And so they actually do this to each other rather than just within themselves. And so basically Zika and dengue immune responses definitely affect each other, but it still is unclear to what extent. So there were some studies that were done. So in 2016, what they found is that if you had a prior Zika exposure, that there was potential for this antibody-dependent enhancement in vitro. And so that's very important for people that maybe were exposed to Zika and then we're maybe going to become exposed to dengue here in the next few years. But then there was a 2017 study that's really important. And I do want to take a moment to thank the rhesus monkey. So not only was it the type of monkey that we found Zika in the first place, but also the studies are done in these monkeys. And so you have to appreciate the lives of the animals that were sacrificed for all of our benefits. And so I do want to give a thanks to the rhesus monkey. But what they showed is that there were basically no cross-neutralizing antibodies that came with the Zika immune animals. But what they found is that these dengue viral loads were super, super high. So basically, they gave a monkey Zika, then they introduced dengue to it, and it had this antibody-dependent enhancement in vivo of these monkeys. But interestingly, even though there were higher viral loads, the monkeys really didn't have a more severe disease. And typically we think of the dengue hemorrhagic fever as being due to these really high viral loads and viremias. So they looked again about seeing what happens if you first give dengue and then see what the Zika response is. And what they actually found is that you can definitely get increased Zika viremia, but the disease wasn't as severe. And also the Zika viremia lasted for a lot shorter of a time. So this is actually really good because it was really saying that prior dengue infection could actually prevent really bad Zika infection and potentially be protective against Zika rather than the other way around of Zika being protective against dengue. The last part of the immunologic system that is a little bit less is actually a lot less well known, and there are many less studies about this, is actually the T cell response. But there's a general consensus that the T cells do play a role and that there's some interaction because a lot of these CD4 and CD8 cells definitely show cross-reactivity, and there are responses when introduced with one virus and then the other one. And so there's definitely cross-reactivity there. But what they're showing is that the T cell responses were really stronger when it was someone who was prior infected with dengue. So they took serum from those patients. Then they introduced Zika to those patients. And what they saw is that there was actually higher levels of immunity against Zika with prior dengue infection, but not vice versa. And so these are a couple of very interesting concepts from other studies that were done. And so basically what we saw is that when it comes to these like convalescent infections, that you really didn't get a lot of great long-term immunity to something like Zika or dengue between the two, but the immune response was much higher if you happen to get infected with dengue and Zika very close to each other. So if you were in the acute phase of a dengue infection, then Zika came in, you had a much higher immune response at that time. And so you could potentially have been protected against Zika if you had a very recent dengue infection. So I'm going to stop avoiding the question. I'm going to go back to this question of, does Zika infection actually confer immunity to future dengue infection? So there was a study done in Northeast Brazil by a group of researchers, and they really hypothesized based on more on temporal relations that they really did think that a prior Zika infection conferred immunity to dengue, or at least contributed to it. But a lot of the studies that we're seeing in monkeys and in labs is not as such. So they recommended doing a what do we call it, the neutralizing study. And so there was a neutralizing study done in 2018, but there was only an N of 21, so it was a small number of patients, but they actually found only 1 out of the 21 serum samples had weekly neutralizing antibodies to dengue after Zika infection, and none of them showed a very strong response. So this is actually kind of saying that prior Zika infection really isn't going to confer immunity to that. However, there's one last thing that we do need to talk about when it comes to immunity, and that's herd immunity. And so what I talked about, the first 7,000 cases in Northeast Brazil, no one actually said this is for sure dengue. We just think it is. And so there might have been a lot of other very minor Zika infections out there. And this might have contributed a lot more to just the Zika disappearing as herd immunity. So basically everyone around got infected with Zika, and now there's no one else to infect. And so that essentially makes the disease process go away because everyone's been infected. So you might be sort of thinking, sense. Dr. Maurer clearly isn't an immunologist, and none of that made sense. So I'm going to try to very simplify our conclusions for this. So what we actually know is that dengue and Zika, they definitely have a lot of cross-reactivity to some degree. But what we see is more that if you have a prior Zika or dengue infection, that can lead to higher levels of dengue viremia when it comes to getting that second infection. But if you get through that second infection, then you can potentially have better immunity. But what they also showed is that if you get Zika after dengue, it doesn't have that sort of same robust immune response. And so you'd really have to get a dengue infection again to protect against dengue. And then we definitely need more research because it's quite unknown. And we're just now trying to learn a lot more about the immunologic mechanisms that play between these two infections. And then immunology alone is unlikely to be the only reason for these clinical findings. And we didn't even talk about vector impacts and a lot of other big things that have been going on in the public health domain here in Brazil. So there are likely a lot of other things that are at play rather than just the immunology behind it. But I do think the immunology plays a big a big part. And so that's kind of where we land. And so thank you very much to Jose Antonio and to Ricardo Guimarães and the whole team at FASE for allowing us to be part of this. Any questions? Good, no questions.
So as this is a section for arbovirus, let's finish with Desiree, and then after we can open for more questions because we can we can talk about not only immune response, but also another factors that Desiree will share with us. So now I want to invite Dr. Desiree Lebeau from Stanford University. Desiree is an expert or has been working a lot on arbovirals across the world, and she'll be talking about unmeasured drivers of arboviral disease, violence, and trash. That's exciting. Thanks so much. So please welcome Dr. Desiree.
Thank you. Good evening, everyone. Thank you for coming. Wonderful to follow Mikey. That was an excellent talk. So I'm going to talk about violence and trash. But first, I wanted to take you from Brazil to where I work, which is Kenya mainly. So I've been working in Kenya since 2003. And I'm working on mosquito-borne viruses, right? Dengue, chikungunya, and other infections. And so there we do a lot of work with children. And what we're trying to do, we're enrolling children into our studies who have fever. We're trying to understand the proportion of febrile disease due to dengue and chikungunya. And then we're collecting a lot of vectors and trying to understand the vector ecology of Aedes aegypti in Kenya and how it confers infection. And then we're tying all of this to climate and trying to predict disease with climate. And so through these studies, we've learned some things over the years. And the first thing we've noticed is that although all the fevers in the health clinics are diagnosed as malaria still, many of them are not malaria, and many of them are actually due to these infections, though the clinics can't actually do the diagnosis because the diagnostics are not there, and the clinical teaching is also not there for healthcare providers to recognize infections other than malaria at this time. But we do find the kids are exposed quite a bit at early ages. We find dengue and chikungunya both on the coast of Kenya and on the west side of Kenya. I failed to mention here, we work in 4 sites. We work on the shores of Lake Victoria in Kisumu and Chilaimbo. This is a picture of Kisumu. And then we also work on the Indian Ocean coast south of Mombasa in Ukunda, Msambweni. So we find a lot of Aedes species mosquitoes at our sites. They are alive and well there, and they are definitely infected with these diseases. And we find that there are certain containers that seem to be more conducive to breeding the mosquito. And so although we find so many different containers, the ones that we actually find that we call productive, the ones that actually have like the baby larvae for the Aedes aegypti, there's just a few of them. Okay, so we started thinking, well, we might be able to target these containers specifically and decrease or prevent arboviral disease. So that's what we started to do. Because again, Aedes aegypti, they don't bite at night. This is the only vector control happening in Kenya. It's the insecticide-treated bed net, and it's for the malaria vector, which is a night-feeding mosquito, right? So this does not work for Aedes aegypti, okay? So we don't have any antiviral therapies, so we pretty much are stuck with vector control to prevent these infections at this time. We have no drugs, we have no vaccines. We can't use bed nets because, again, these are day biters. They're very anthrophilic. They love to feed on us. They love to breed in our containers. So you have to think about them differently. You can't use the same control. And there were studies done in Kenya and on the coast where we're working showing that only 15% of people practice larval source reduction, which is cleaning up your stagnant water and decreasing your mosquito breeding in your yards, but 50% used bed nets, right? So there's this proportion of the population that's maybe concerned about their health and could be empowered to protect themselves against another type of mosquito. And this has been shown to be very effective. In India, there was a study done that targeted women's group. First, they figured out that these animal troughs were the big producers of Aedes aegypti in their communities. And so they came up with a culturally appropriate and acceptable cover. And they were able to reduce the amount of Aedes aegypti by 95%, right? So low cost sort of community appropriate activities can work in solving these issues. So what we wanted to do was take invisible risks and make them visible. This is my middle son, Everest, looking at a microscope, looking at all of the Aedes aegypti larvae in the backyard of someone's house in Kenya. So take these invisible risks and bring them to community awareness so that people, have the knowledge and they can empower themselves to protect them and their families. So the first study I'm going to talk about is the trash study. Okay, so I work with a fabulous PhD student named Jenna Forsyth at Stanford. This is Jenna. And so we have this project, which is called Engaging Schools and Community to Reduce Mosquito-Borne Vector Disease in Rural Kenya. And so what we wanted to do was to design and implement and evaluate a school and community source reduction intervention to improve knowledge and behaviors and abundance of immature mosquitoes. And so we spent a year just designing the intervention. We met with a lot of stakeholders, a lot of community members, a lot of village leaders, a lot of Ministry of Health, schools, teachers, and really had a lot of design workshops to try and understand both the drivers for good behavior and the barriers to larval source reduction in the communities we were working in. We did a lot of formative research, a lot of piloting, a lot of focus groups with people to understand, and then a lot of vector work in the community to understand the baseline of what we were dealing with as far as the vectors went. And then we pilot tested it and reiteratively designed our intervention. And so then about a year ago, we started to do the intervention in schools. And so we took 10 schools, 5 of them were a control school, 5 were our case schools, and we did our intervention, and I'll talk to you about what that is. And then paired with that, we did a community-based intervention where we went into the households and spoke with the mothers and also just had one-on-one conversations with them about Aedes aegypti and what they needed to know about the mosquito other than the malaria mosquito. We did baseline mosquito surveys, and then we also did baseline knowledge, attitudes, and practice surveys. And we came back right afterwards, did all of that again. Then 3 months later, we did it all again. And then a year later, we did it all again. And we did this in the rural sites in Kenya. And now this year, we're doing the intervention in the urban sites in Kenya. So what did we learn? Well, everybody knows about malaria, which is great. But then past malaria, there's not a lot of knowledge. The greatest concern is about night biting mosquitoes that cause malaria. People had limited awareness of the life cycle, that there were other mosquitoes that bit during the daytime, and that source reduction could matter. And then when we did our entomology surveys, we found, most entomologists, when they do a lot of entomology work, they focus on the container, right? Like these containers are bad, like tires are bad, or like buckets are bad. But what we came to realize, because we're not entomologists, was, well, it's not exactly the container. It's sort of like what the purpose of the water in the container is. So if you have a container that's holding water and the water's got no purpose, it's going to breed Aedes aegypti mosquitoes. If your water has a purpose, it's going to be used up before the mosquitoes can breed, because that takes time, and it's not going to be so much of a problem, right? So we actually found that most of our larvae were actually in containers in the community with no purpose. And that can be a lot of different containers. It could be tires, right? It can be buckets used for sanitation, and it can just be trash laying around with no purpose, right? That's collecting water. So we went into the schools. Each school we went in for about a week, and we spent each day sort of doing lessons about mosquito life cycle and behavior, teaching them that different mosquitoes cause different diseases. We used some art drawn by an art student at Stanford. Her name is Eleanor Frost. And we did a lot of activities to make it fun, right? Like unlike here, which is not fun for you. You're sitting here trying to listen to me stay awake after dinner. It's tiring. It's hard. We interacted a lot with the kids. We gave them a lot of homework. We played games. We made up this mosquito tag game. There was art and poetry, and it was a lot of fun. Then community, I mentioned, we went door to door, and then we had a lot of combined activities. We did community cleanup, which I'll talk about, and some tree planting. So this is just some pictures. This is Joyce. And this is one of our mothers. And then this is just a typical homestead in Kenya. This is some of the games we were playing with the kids. Mosquito tag. There was poetry. Some of the students memorized this and recited it to us. It was pretty adorable. The cool thing about Swahili is you can rhyme chikungunya easily. And we made them mosquito hunters. We gave them badges. We armed them with protection of their communities, and the kids were really into it. And then what started happening was that, after the first day when we taught kids about what the immature forms look like, these little worms, these larvae, we're now go out. Your homework is go out and find these. And all the kids would come back the next day and be like, we found them. We're like, where did you find them? And they're like, in the piles of trash in our neighborhood. So me and Jenna were like, oh, Jesus, what are we going to do now with all of this trash? You know, trash was not part of our project. So we decided to pit the schools against each other and have these sort of like recycling days, okay, where the kids would collect all of these like no purpose containers in their community and bring them in, and we'd weigh them. Then we had to figure out what to do with them, which I'll tell you what we did. But and unfortunately, there's no recycling in the entire country of Kenya. So here, you would collect all that, and most of it's plastic water bottles, and you'd recycle it. There, unfortunately, we cannot recycle. There is no recycling. So our choices were burn, which is done a lot, or bury. So we ended up building, like, making huge pits and burying this stuff. So 250 school kids from 5 schools collected over 17,000 containers in a month, weighing over a ton. And it was plastic. Most of it is plastic water bottles. We took all of the trash we possibly could and we repurposed it. We repurposed the containers and we planted 4,000 native tree seedlings, the trees that the kids in the community wanted. And we grew up 4,000 trees and we gave them to the kids, we gave them to the schools and the mothers. So we call this our like trash to trees program. And this was very effective, but you know, it needs to go on and on and on to be sustainable. And really we need a recycling partner in Kenya. We need something else, right? As far as the study itself, as I mentioned, it's ongoing. We did find some significant gains. We've looked at the 3-month data so far. And so people learned after we taught them about mosquitoes, which is good. That's what you'd hope for. There were some misconceptions that we wanted to focus on. Like, for instance, the mothers would often say, if they had water, say they had a bucket with water that they were going to use for washing or something, or maybe eating, drinking, food preparation, and then they would see the mosquito larva in the water, they would say, oh no, if we drink that water, it's going to make us sick now. So then they would just leave the water. So all of a sudden, purposed water became like non-purpose water, which was exactly a bad thing for us, right? Because all of a sudden that water is going to sit there and just breed mosquitoes all day long. And so we were able to change that misconception, which made us happy. And this one I think is really important. When we initially started this study, we actually wanted to use children as change agents. You know, I'm a pediatrician. I believe like children are like the future and can change the world. And so I was like, all we really need to do is empower the children and they're going to save their communities. But then what happened during our formative research, when we actually started talking to the mothers and doing the focus groups, is we learned that actually children don't actually tell their parents what they learn at school. And then the parents don't ask them. And so this wasn't going to work, right? And so through this study, we actually increased the communication between the parents and the children. Like, the children were like excited at school, so they came home and told their parents what they were learning, which was nice for us to see. We were excited about that. And we also had some increases, intervention versus control, when it comes to reported behaviors and source reduction, right? So parents, we would sometimes go to households, and in this community in South Kenya, there's a ton of coconut shells. And of course, you know, Aedes aegypti only need a tablespoon of water. So you have all these coconut shells and they're breeding mosquitoes. And we went to this one house and literally like the mom had put the coconut shells like on her fence, like upside down. Every coconut shell was upside down. And so there were people who were really changing their behavior. When it comes to the vectors, though, it's really tricky because unfortunately, the effect of our intervention is smaller than the effect of climate, as you can imagine, right? So like you get a lot of mosquitoes after it rains, and that oversights and kind of overshadows anything that we might be doing with our intervention. So we're trying to still figure out how to deal with the vector data. So to conclude this part, we showed that source reduction interventions can be effective if they're designed with an understanding of the social and entomological context. We found that our container cleanups were a successful way to engage the kids. And structural changes such as improving access to reliable water sources, solid waste collection, disposal services might actually have more impact, right, than household behavior change on actually reducing the burden in the communities. And we're still analyzing and trying to figure out what more we can do here. So during this time, you know, all this trash, you know, I've like learned a lot about trash, and there started to be studies like this, but blaming. So every year in Mombasa now for the last 5 years, we've had outbreaks of dengue. And this is very new. You guys have been having outbreaks of dengue here for decades. But in Africa, where, you know, dengue is supposedly originated, it's very endemic and it's hyper endemic. And there aren't these large city outbreaks that you see here. It's a very different sort of transmission cycle. It's just low level all the time, year round, instead of these huge outbreaks. But we started in 2011 to see yearly outbreaks of dengue in Mombasa, which is a really big port town in Kenya. And it was people started thinking, oh, you know, there's people aren't collecting garbage, and all this garbage is breeding mosquitoes, and this is why we're getting sick. And so we had this idea after that, and with this study, we have all this trash, right, that we know is there, we want to collect, and we want to get rid of this trash somehow, right? But we don't have the partners to do it. And so we had this idea, well, you know, what if we could somehow take this trash and turn it into money? Okay. So this is what we're trying to do now. So this is the second project I want to talk to you about, which is trash to treasure, right? Collecting trash for profit to reduce mosquito breeding sites in Kenya. So the plan for this, and this is a brand new project that just got funded through BOVA, which is building out vector-borne diseases in sub-Saharan Africa. Our plan is to actually have a program where we're collecting trash, right? So this is going to decrease our disease incidence. And then we want to give it a purpose, right? We're going to have an entrepreneur program where we have barazas, which are these community gatherings where we call for applications from people who really want to come up with good ideas about how you can take a plastic water bottle and make it into something useful that then would alleviate your poverty, right? And you know, create economic incentives and decrease poverty while cleaning up the environment. So this is our plan. And then the reinvesting the profits. And so this is what we're hoping to do now. So this project, we're assessing the potential for community-based recycling that engages aspiring entrepreneurs to repurpose trash for profit while improving health by reducing arboviral disease transmission and alleviating poverty. So phase one is what we're in now. We have become like trash people. We've tried to meet with, I mean, people are doing incredible things across the world with plastic water bottles. I'm going on my own, like, no, everyone in this room, please, no single-use plastic. It's a terrible thing for our planet and our people. It's like, we have to do something. And so my lab, we have other projects that are related to this, but you know, for this project, we're identifying target communities, we're figuring out how much waste there is, and then we're scoping. Right now, we're really scoping local solid waste and recycling industries or partners and stakeholders in Kenya. And then we're trying to link them with other members of the community. There are people who actually collect trash. There's like trash streams, and there's already revenue generating streams when it comes to trash. So we're trying to figure this out. And then we're going to have this business incubator program after we identify these local entrepreneurs to really collect them with the trash collectors and then market opportunities and help them grow their businesses, and then measure the impact on their bottom line. Are they making profit? Is it sustainable? Is the trash going away? Is the disease incidence decreasing? So this is our plan for this project. Then I have this dream to build a lot of tire playgrounds in Kenya, because again, tires are one of the, a non-purpose container, which grows a lot of 80s, just like here, right? And so I have all these dreams. I'm always looking for funders who want to do tire playgrounds in Kenya. This is just a pet project that I always like to put up there. Okay, so that's the trash part of this talk, right? So maybe something you don't think about all the time when you think about mosquito-borne diseases, trash. But maybe you have thought about it a little bit, right? I'm sure here in Brazil that trash has been probably linked, and sanitation has definitely been linked to arboviral disease. The next topic I want to bring up briefly is violence, right? So what about neighborhood violence? Is that like another unmeasured factor that puts people at risk for disease? And hopefully by the end of this, you'll say, yes, it is. So I'm going to just do a little bit of background, talk to you about a study that we did in Cali, Colombia, and then, you know, some newer stuff happening in Brazil right here, and finish up. So we know that security is closely linked with public health, right? And we know that violence in the world is not equally distributed, right? You can walk across any city or any small place in the world and know that there are places that are more dangerous and places that are less dangerous. That's how violence is. Low and middle income countries bear a disproportionately high burden of violence, right? And related health outcomes, right? across the world. So not only is violence heterogeneous within one space, but across the world, violence is often higher in low and middle income countries. The low and middle income countries, unfortunately, bear more than 90% of violence-related deaths, and mortality rate due to violence is 2.5 times greater than in high-income countries, right? And violence, the way people are starting to think about violence is changing, right? A lot of us measure health and disability adjusted life years. I think you guys know what that is. So the DALY, so it's the amount of life lived at less than perfect health, either because you've died or because you're living with some sort of condition, right? And violence actually sneaks its way into a lot of the main causes of high DALY rankings in the world, right? So a lot of injuries, of course, and mental health illnesses and infections are actually related to violence. And so we're actually starting to think now, just like this happened with alcoholism maybe a few decades ago, but really thinking about violence as a disease, right? It's not a problem. It's actually a disease. It acts just like an infectious disease, actually. It can be transferred from one person to another. There are pockets of it. It's heterogeneous. So it's almost like reframing how we think about violence, because that will bring new tools in order to deal with violence. So I'm going to talk to you briefly just about this little Cali project that was led by a postdoc of mine. Her name is Amy Christosic, and she did her PhD work in Cali. And so first what we did was we just overlaid arboviral risk. So Cali, just like here, has a lot of dengue, chikungunya, Zika, right? So we just took the map of Cali, Colombia, and we overlaid arboviral risk, highest in red here, with homicide risk, right? And the maps are similar, okay? So the same places that are hotspots for violence are also hotspots for arboviral disease. And we started thinking about, well, like, why is this, right? Because there's no, like, it's not direct, right? It's not like if you, if you're having violence at home, it necessarily means that there's more mosquitoes in your house, right? So what is it? Like, how are these correlated? Like, why are they connected? And it's partially has to do with actually access to healthcare, right? As you can imagine, right? So access to acute lab testing is also not equally distributed, right? We all know access to medical care. The rich have a lot more access than the poor, right? And so the map looks the same, right? We have what we're looking at here, the red circle is the relative risk of having lab confirmation, right? And red means you're not getting your lab confirmed, right? Whereas black means you are getting your lab confirmed. So again, there's inequity. We're talking a lot about equality and equity in global health. And so there's inequities here when it comes to access to care. And again, this is just showing access to clinical care and the lab testing both together are not equally distributed. Again, you have hotspots of disease that aren't being measured. And of course, homicide risk is also not equally distributed, right? So there's spatial clustering of homicides, and homicides are in that same area where people don't have access to care. Now that does make sense, right? If you're living in a violent community, you're not going to have the same healthcare options probably as nonviolent communities. Healthcare workers aren't there. There aren't clinics there. You know, the distribution of testing is not there, right? So again, this region really overlaps with the high dengue risk and the low testing, right? So it's all overlapping. And so then what Amy did was she modeled it. So she actually controlled, because you may say, well, oh, this is just all poverty, right? It's just because you're poor. And so maybe, you're not cleaning up your environment, and that's why you have like the extra mosquitoes, whatever. But even when you control for SES, you actually correlate homicide risk or violence with an increased risk of having dengue, okay? And it not being measured, right? It not being tested or confirmed in the community. And so I'm not going to go through all of this, but if Amy was here, she would be very inspirational about this, because it's really true, right? Like it's like neglected populations. We have this all over the world, right? People who are neglected for different reasons, that are faced with all sorts of difficult health choices, difficult life choices, and then they're also not getting healthcare, and they're also in violent communities, right? Very difficult to have health in that sort of setting, right? And so you end up with what you end up with, and this is the painful part, and the part that we really have to end, is that you end up with all these unmeasured diseases in unmeasured people who are just neglected, right? And so what's happened in Cali is like they do all of this great dengue surveillance, and they know like where all the hotspots of dengue are, except for the violent hottest spot of dengue in the whole city, which is that area on the bottom right there that I keep showing you where they're not measuring anything. They have no idea how bad it is, but when you go in there, it's very bad, right? And so Amy just wrote a K grant to try and serve this community, truly, is what she's trying to do. So this is also happening in Brazil. So there was a paper from Fortaleza that was just published last year, well, December of 2018, where they actually said the occurrence of violence was a strong and consistent predictor of high dengue incidence. So it's happening here too. It's not just Cali, right? It's across our world. So I want to conclude now. So arboviruses are common. It's happening in lots of parts of the world, and they're causing large outbreaks. We really need to take holistic approaches to improve health. And when we talk about something like arboviruses, which have the vector and a lot of human behavior and vector behavior and all of these different things, climate combined, we really do need to take a holistic approach and think outside the box, not just health, right? But things like trash and violence. Because these unmeasured communities need a voice, right? And these health risks can have true impacts on outbreaks and prevention. Okay, thank you very much. Oh, hold on. I have 2 more slides. I always have to do this. So all these research projects, we do a lot of research. As any of you who have done research, you know, the research money comes and then it goes, and you're always trying to do this. But I always like to bring up that through our research, we train a lot of students, both in Kenya and elsewhere in the world. And I really believe that training all of you guys back there, this is the sustainable part, right? Because, you know, we get excited with you, or you excite us and inspire us. You know, we work together, and then you guys keep going, right? Long after we're dead and old and useless, you keep it going, right? With your new ideas, and you train other students. And so this is how we're going to change the world. So I always say, for me, students equals sustainability in the populations we serve. I also just want to bring up, I have huge teams in Kenya that I work with. I'm just a person here, you know, telling you about our research, but this comes from a lot of different people at all different levels. So from partner institutions as well, including Emory. Soon, University of Miami, right, Mikey? And then I always want to thank our study participants, right? So we have communities and children who continually volunteer to be in our studies. Without them, I'd have nothing to say, and we wouldn't be learning all of this important information. And then I thank you for your attention. And I always want you to remember, if you think you're too small to make a difference, try sleeping with a mosquito. Thank you.
Wow. Thanks, Desiree. We have a few minutes for questions or comments, so I will open a moment for you guys. If you have questions, comments, I want to start this. So it's amazing. First, Desiree, I told you that before. This project in Kenya is a inspiration for us. So, and we have been working hard here, as we share from the beginning of this week, together with Juan and Emory, projects that always had an impact in the public health policies. And I think this is a reality, what we are doing at Kenya. Of course, the reality in Brazil is completely different from Kenya, but we can learn a lot of what are you doing there. Thanks so much. And Mike, so I think the answer is yes, all right? So this year we are seeing, but we have seen this cross reaction with dengue and Zika, and some papers have been published recently, including one from Salvador that shows something very interesting in this field. So that's exciting. So extra comments, someone? All right. Hold on one second.
I promise I won't screw you over. I don't even need a microphone.
Hello. I'm not used to using this, so excuse me. Did you find any cross reaction in the literature about chikungunya with dengue, or was it just?
I didn't look into chikungunya, but actually in some of what was interesting about the last couple of studies I talked about that were up in the Northeast is that they actually still saw like pretty high incidences of chikungunya at the time when Zika and dengue were totally going. So I didn't look specifically into the immunologic side of that. So I'm not an immunologist or
Okay. No, absolutely not. So chikungunya is a togovirus, totally different family, very different, not even a flavivirus, very different than Zika, dengue, West Nile, yellow fever, all of the flaviviruses. And so there's no cross-reactivity at all between chick and dengue. None.
What about malaria?
Malaria?
Yeah.
No.
No. Okay.
Hello, good night. My name is Daniela, and first of all, I would like to say congratulations to all of you because the majority of disease that we are discussing here are so far away from you, and you are so interested in. So I would like to say congratulations. You are inspiration for us, really. And and the second, I would like to question for Desiree, because we saw that the results in Kenya were amazing, and I could remember when I was 12, and in a school project we walk around a neighborhood of our school doing speech from people about dengue, and although these campaigns here in Brazil, what we saw that it's that each year by year the number of cases of dengue are still growing, you know. And I would like to ask you what you think about what we must do to improve this number.
Yeah, that's a good question. So the first part is the reason why I study these infections is because they're the most amazing infections. They're so interesting to study. I mean, it's a really interesting cross section between like virology, clinical medicine, vector entomology, and then climate. I mean, there's so many different things to study. So it's my honor, great honor, to be able to study these things. I'd say it's very difficult, right? I mean, Aedes aegypti is clearly really, really difficult to control, right? There was a period of time in the recent past when most of Latin America did have Aedes aegypti under control because they were using DDT, right, and killing off the mosquitoes really well, right? But we can't do that because it's toxic to the environment. So I think, unfortunately, because we don't have drugs to treat people, right? We don't have vaccines, although I think vaccines will be part of it. Even when there is an effective dengue vaccine, I think it's still really important to remember that surveillance and control of the vector is really what we need to focus on. Because when you control Aedes aegypti, you're also, if you give a dengue vaccine, you're protecting against dengue. But if you control Aedes aegypti, you're protecting against dengue and Zika and chikungunya and yellow fever and, the list may go on, who knows. So I think there are new, like, sort of novel strategies now, right? The vectors are becoming resistant to our drugs. We have a sort of so I think it's really important for us to focus on better prevention. I think it's going to be a mixture of things, right? So it'll partially, maybe it will be vaccine and improving herd immunity, right? So you can blunt the cycle. I think it's vector control, right, done by vector control agencies, but then people on the ground, right, mobilizing the community to clean up their environments and do what they can to recognize that that is a dangerous thing that's in their house and they need to kill it, right? I always tell my kids, so my children are sort of messed up. I have 3 young boys, because like when they see a mosquito, it's like someone's pulled out a gun. They're and they just, oh my God. And I just always remind them, I'm like, okay, they don't fly that fast and you can see them. So like follow them and kill the mosquito, so to empower people, it's what they can do, right? Because it's true, luckily. Anyway, yeah. So it's going to take a mixture of education, vector control, and so forth.
My name is Marcos Vinicius. I would like to congratulate you both the same way that my colleague did. And I would like to ask you, how did you suspect about the relation between the violence and the disease?
That's a difficult question. How did we even begin to think about that? I think um, I think it's just that we've been following. So so Amy did her PhD in Cali, and she recognized, like, she did it on sort of kind of what I described at the beginning of my talk in Kenya, just about the epi and risk factors and disease and clinical outcomes. She sort of did that work, including the vector work in Cali. And I think she was always impressed by the fact that there's, it's sort of what we call in the US, it's like the elephant in the room. It's like there's the part of the city that's actually the dengue factory of the city that's supplying all the dengue to the rest of the city that no one's surveying, no one's treating, no one's going in there, right? And so she says, "What is this? This is terrible." And so she started to think about violence and how violence was sort of affecting people's behaviors, and then really causing these long-term negative outcomes from that. And then when the switch started happening a few years ago, where people are starting to now think about violence as an infectious disease, she started to think, oh, I wonder how related violence is to the outcomes that I'm seeing. And I think that's how it all began.
Comments? We have more. 1 minute. No? Okay, we are good to go. Okay. All right. Thanks so much, Desiree. Thanks, Mike. So now we will change completely the subject, and we'll be talking now about viral diarrheas. That's exciting. Let's hear what Juan Leon wants to tell us. So please welcome Dr. Juan Leon, and he'll be talking about epidemiology and public health impact of viral diarrheas. Thanks, Juan.
Okay, I'm going to try to match the passion of both Mikey and Desiree. They love, well, their energy, but they love arboviruses, and I love diarrhea. So I'm going to try to tell you and share with you how wonderful diarrhea is to study, not to have, of course. So I belong to the Center for Global Safe Water in the Global Health Department, and we do a lot of work on viral diarrheas. Now, this came to us more directly in 2015, and I'll share a little bit of what happened in 2015 with you in just a bit. But as a place to start, I just wanted to share that. No, no. Let me try that. Perfect. There we go. Okay. So I'm personally very interested in understanding different enteric pathogens. So studying these different pathogens, for example, viruses or bacteria that may be in young children or the elderly or in food, how they get transmitted, and when somebody swallows them, then what happens in the person. And we use two different tools: epidemiology, which is where I got my MPH, and immunology, which is where I got my PhD. So I tried to combine the two areas in order to study some of these conditions. So now what I wanted to share with you, in 2015, this came to Emory and affected us in a very big way. So I want to show you this very small report about what happened to us at Emory University related to these enteric diseases as well.
Developments this noon about what made dozens of Emory University students sick. University officials emailed us less than an hour ago to say tests confirm it is a norovirus outbreak. Last week, 89 students got treatment from campus medical services. Officials say they are already seeing a drop-off in the number of cases. Norovirus is a highly contagious intestinal virus.
So Emory University was in the news, not for a good reason, but because we had an outbreak of norovirus that affected many of our students. So all told, we had about 200 students that were affected by norovirus. And this is a common disease in many university campuses in the United States and worldwide as well. It started a few weeks before Thanksgiving, which is a big holiday in the United States. So on November 12, 2015, there was a dormitory where many freshmen lived. And one of the freshmen started reporting nausea and vomiting, and so much vomiting and diarrhea and abdominal pain that they had to be taken to the emergency room of Emory University. But they weren't the only one. Many other students that same day started also falling sick and calling. So of course, the emergency room was overwhelmed at Emory with all these students with pain, vomiting, diarrhea, and they just kept getting worse and worse as well throughout the rest of the university. So then our team was called that morning, and they said to us, "We don't know what this is. What this is? What do you think it is?" And of course, we do a lot of work on viral diarrheas, and we said it probably is norovirus, but we have to study it. So we took some stool samples and we put it in a machine called BioFire, which was used to initially diagnose the first Ebola patients at Emory. Which in a matter of 2 hours through molecular testing is able to give you a result. And then it ended up being norovirus. So with our infectious disease fellow and an MD PhD student, they were able to collect the specimens, test the specimens, and we confirmed that it was norovirus. Then the next stage was to see where did it come from. And of course, you think food immediately. So we tested the food, and we couldn't find that it was from the food. We also tested different environmental surfaces. And we did find norovirus on different surfaces, on the elevators and also near the bathrooms, et cetera, that matched the same strain that we detected as well. So at the end of the day, we did not know what was the origin of norovirus. So instead, we shifted over to different communication campaigns to prevent, because we were very scared that students would go to Thanksgiving and share norovirus with their families, with their grandmothers, with their children, with the food. And that was very scary for us. So we did a lot of public messaging to prevent that as well. And just like us, norovirus affects many universities in the United States. It's very underreported. Our sister school, Georgia Tech, had norovirus outbreak last year and also 2 years ago, and we helped them with their outbreak as well. And the symptoms, as with many viral diarrheas, are you have your diarrhea, your vomiting, nausea, chills, aches, stomach pain, headaches, and fever. So you just feel unwell for a very long time. So norovirus is not the only viral diarrhea that is important worldwide. You have many of these that are listed here, but the two really most important ones are norovirus and rotavirus. And rotavirus is most important, as all of you know, in young children, but also in the elderly when they start losing the immune response against rotavirus. And then you also have outbreaks due to some of these other viruses, sapovirus, astrovirus, and adenovirus, but to a lesser degree. So because norovirus is so big and important, I'm going to focus the rest of my talk on norovirus specifically. So this is norovirus from the electron microscopy images. And in terms of risk, we've calculated in the United States what is the lifetime risk, and each year how many different cases do we have. So in general, in the United States, and we haven't calculated it for other countries, every person probably has norovirus at least 5 times each year, and 1 of 5,000 individuals may die as a result of norovirus, which translates to about 21 million different episodes each year, and about 800 deaths linked to diarrhea due to norovirus each year in the United States. And if we think about food in the United States, norovirus causes most of the known foodborne outbreaks, much more than bacteria or other conditions. And bacteria are combined with salmonellas, the E. coli, everything. Norovirus is really the main agent here that we're talking about. And when you think about transmission, you think fecal oral. Basically, you have feces with norovirus that either you eat again or somebody else eats your feces that has norovirus. It's basically what is happening. And it is transmitted via surfaces, water, fingers, food, and many conditions as well. So don't eat your poop and don't eat other people's poop is bottom line in terms of public health interventions for norovirus. Norovirus has been evolving a lot due to human pressures. So when I started work in norovirus in 2007, we had about 4 or 5 genogroups. And now in 2018, 19, we've expanded to about 7. About all the different genogroups, the one that cause disease are 1, 2, and 4, but the really main culprits are 1 and 2, and really it's 2 that is the main cause of a lot of the outbreaks that you hear about nationwide, in the United States, in Brazil, etc. And usually in universities, it's genogroup 2 that causes all the university outbreaks. So you may ask, why are norovirus such an effective pathogen? Why did so many people get sick at Emory and affected us? So we're going to answer all these different questions during this talk. Is it infectious? Is there a lot of shedding and high titers? Does it persist in the environment? Is it resistant to disinfection? Are people susceptible? And is there immunity to norovirus? Many similar questions that we're going to answer together. So unfortunately, when I started working on norovirus, there are no animal models or tissue culture models. So instead, what you have to do is you have to use human beings as your model. So what you do is you take feces from somebody who had norovirus, you purify out the virus, you test it to make sure it has nothing else but norovirus, and then you give it to somebody else to take. And you keep them in the hospital for 5 days. So we had a lot of very brave volunteers who allowed themselves to become infected with norovirus, have diarrhea and vomiting while in the hospital. Then we have them come back for follow-up visits, and we collect serum, saliva, stool, etc. So what I'm going to be sharing with you is a lot of the results of the study of many hundreds of volunteers who decided to take norovirus to help science and for other reasons as well. And we'll talk about the other reasons later too. So the first question is, how infectious is norovirus? So what we did first was we gave different doses of norovirus. And here is a number of people that were infected. Immediately you can see that only 2 viruses was enough to cause infection in people. So what that means, if you then translate it to the ID50, it's about 18 viruses, which is ID50. But what this means is that if you take the head of a pin, that amount of feces is enough to cause norovirus in about 1,000 people. So very little feces causes a lot of infections in many, many people due to norovirus. When you think about the different infectivity, we did a lot of work comparing 2 different strains of norovirus. As we talked about, there's 7 different genogroups and many different strains. So we compared 2 different ones. Here is the probability of infection. Here is the dose at the bottom. You can see that the 2 strains look differently. So for example, Snow Mountain virus has a very high level of infection with a very short dose amount, whereas Norwalk has a more gradual dose. So different strains of norovirus are going to behave differently in terms of causing more or less infection. And the same thing for symptoms. So symptoms on the y-axis, independence on dose, different strains are going to be more or less symptomatic. So some may cause more diarrhea, more vomiting, more intensity. And so that's something to keep in mind as you think about the different strains as well. So in terms of answering the question, yes, norovirus is highly infectious. You need only 2 viruses in order to cause infection in a person. So my next question is, how long does norovirus shed for? And does it have high titers? So again, we turn to our human challenge studies to answer that question. So here are all the people that got infected in one human challenge study. So we had 22 volunteers, and we measured their shedding, which basically is we look for virus in stool via RT-PCR. So we collected stool specimens every single day, and we had some brave students in our laboratory who would take these stool specimens, the vomit, and measure it and test the vomit and the stool for norovirus. We also looked at the symptoms as well. As a side, one of the first questions we ask somebody is, if you smell diarrhea or vomit, will you be okay? And if you answer no, then you cannot work for us. If you answer yes, then you can work for us, because you have to work with a lot of vomit and stool if you work with me. So what you can see is that symptoms go away usually after 3 or 4 days, but shedding persists up to like 8 or 9 days and even beyond 2 weeks of time. So you have a lot of people that are look healthy, but they are still shedding norovirus in their stool. So about 18% in this challenge study shed norovirus. And when we looked at how much norovirus they had in stool, they had about 10 billion norovirus in 1 gram of stool. So you may think, how much does my stool weigh? So every day you give a lot of stool, and it's about 300 grams to 600 grams each deposition. So you can multiply very quickly every single day how much stool you give, how much norovirus you're giving to the environment potentially as well. In another study, we also saw that many of our volunteers shed beyond 3 weeks as well, norovirus into the environment. So in answering the question, yes, there is long viral shedding for some people, depending on healthy volunteers, and you have high titers of norovirus as well. So the next question that we ask is, how long does it last in the environment? And I'm already seeing a lot of shocked faces in the audience, which is good because people are awake and responding, but it is pretty concerning. So when we think about the environment, I want to ask you a question. And this is a question that we ask ourselves. So if you put norovirus in water and then give it to somebody to drink, how long do you think it will take for norovirus to become inactivated? So will norovirus become inactivated after 1 day, 1 week, 1 month, or even more? So let me just get a show of hands. How many people think that after 1 day, norovirus will become inactivated? Okay, so about 6 people. After 1 week? Okay, a lot more. After 1 month? Okay, a few more than that? Okay, 3 brave people. So let's go ahead and answer that question together. So again, we did our brave volunteer study. We mixed norovirus with water, and we stored it at room temperature in the dark for many days, and then we gave it to the volunteers to drink. So here I'm going to show you how many days the norovirus was in water, and then how many infected volunteers we ended up having. So our control, we mixed norovirus with water, gave it to a volunteer, bam, everybody got infected. Expected. That's good. Not for them, but yes, for the study. So then 1 week, both volunteers got infected. So those that said 1 day, not so much, 1 week maybe. So then we said, let's try 3 weeks. And nobody got infected. So we were like, yes, okay, so this is good for public health. Norovirus can become inactivated in less than 3 weeks. So then we went and tested 14 days, and both people got infected. So we thought, oh, maybe this is strange. Maybe this is just statistics. What if we go back and test 2 more people? And when we did that, 1 person got infected. So we said, oh my gosh, it is more than 21 days. So we tested 1 volunteer, and then we tested it at 2 months because we ran out of money. And we said, let's just throw all our money at the last time point. And after 2 months, 2 people got infected. So we said, we can't test anymore because at this point, it's a public health hazard. If you have norovirus in water, it's going to infect people no matter what. So that's the answer to that question. We then asked, how long does norovirus last on surfaces? So these are surfaces in your kitchen. Ceramic, your knives, your countertops, etc. And so we put norovirus on these surfaces to see how long it would last. Here we're just testing RNA. So we don't know, we never had people like lick the surface to see if they got infected. So here we're just looking at RNA specifically. Basically, it lasts, different surfaces last less, but many surfaces that you use in your kitchen, norovirus is going to persist for many, many weeks on the surface itself. Ceramic, porous surfaces, a little bit less, more inactivation. The next question was on people's hands. So again, we called more students, more volunteers. Hey, can you put norovirus on your hands, and how long will it last on your hand? So we had those poor students sitting in the tissue culture room, just kind of like that, with norovirus on their hands to see how long it would last. 0, 15, up to 2 hours. And after 2 hours, the students were like, we cannot sit here for 2 hours just waiting to see what would happen. So again, here we're just testing RNA. We can't have the volunteer lick their hand. It's just RNA. And basically, norovirus RNA just stays. So if you don't clean yourself and wash your hand after you go to the bathroom and you have norovirus, you're going to have a lot of norovirus on your hand for a long time. You're going to share that with your neighbor. You're going to put that in your feijoada. You're going to put that in your water. So that norovirus is going to last for a long time. So the answer to environmental persistence is yes, it will last on water, surfaces, and human hands. So the next question is, can we inactivate it in different ways? So one of the things that we tested is, since hands are so important, how can we inactivate it on hands? So again, we called back our volunteers and we tested hand sanitizers and liquid soap to see if they had any effect. And we had, each finger had a different treatment, whether water or hand sanitizers or soap, etc. And here you can see the log reduction. Basically, bigger is better, smaller is worse. So in general, if you don't do anything, you don't have very much reduction. Hand sanitizers, alcohol-based sanitizers, which you use in the hospital, are not very good at norovirus. Though many companies like Gojo and Ecolabs are starting to develop new hand sanitizers that do work. And if you go on a cruise ship, they're not really going to help say that hand sanitizers are good because on cruise ships, we get a lot of norovirus too. Hand washing does seem to work. It doesn't work as well. It's only 1 log reduction, but at least it's better than alcohol-based sanitizers as well. So hand washing right now is still the best way to protect yourselves from norovirus as well. Okay. Another thing that we were interested in asking is, how can we protect food from norovirus? And one of the things that we did is a lot of food, a lot of norovirus gets transmitted through shellfish. So how many of you like eating shellfish, like oysters or clams? Okay. So about a quarter of you like shellfish. Now, unfortunately, you know, shellfish are filter feeders, so they concentrate all the pathogens that are in the water. So every time you eat a shellfish, you're taking a risk, but it's still very delicious. And so we wanted to protect you from the shellfish because many people like eating shellfish raw. And so one of the treatments that people do is this thing called high pressure processing, which is a big pressure cooker where you condense your food. And you can see that the berries and the ham is not affected. But if you put a styrofoam, it's squeezing like a pressure cooker. So for Vibrio cholera, to protect you from Vibrio cholera, you treat oysters at 200 megapascals. And that's very commonly done in the United States and many other countries. And that protects you from cholera. But we wanted to ask if it also protects you from norovirus. So again, we invited our volunteers to come eat shellfish with norovirus. And we, of course, had to taste the shellfish too. Some people were like, but I'm vegetarian, I don't eat shellfish. And we said, well, you're in the study, you have to eat the shellfish. I don't like the taste of shellfish. So we learned that if you eat shellfish with chocolate milk, it makes it not taste so bad. But for other people are like, I love shellfish, can I have more shellfish? So this is what we did in our study. We put shellfish with norovirus and we fed it to volunteers. So if you remember, cholera is inactivated at 200 megapascals, but norovirus laughed at 400 megapascals. So people got infected at 400 megapascals. And it was only when we put it at very high pressures of 600 megapascals that norovirus was inactivated. Now at 600 megapascals, your oyster is boiled, and nobody wants to eat a boiled oyster. It's not tasty. So at least high pressure processing at this time will not work for norovirus. It's good for cholera, it's good for bacteria, but it's not good for viruses like hepatitis A and norovirus as well. So finally, so the answer to the question is yes, it is resistant to disinfection and inactivation, but currently we don't have the best tools to inactivate it or to disinfect it as well. So the next question was on susceptibility and immunity as well. So this is the work of many of my colleagues and our group as well. So the answer to that question is that there are 2 levels of protection with norovirus. Similar to HIV/AIDS, you have a genetic component that protects you. Like in HIV/AIDS, you have the CCR5. And in norovirus, you also have receptors that protect you from norovirus. And of those that are susceptible, some become infected, and due to immunity, some are protected. So I just want to walk you through some of these mechanisms as we understand them right now. So we understand that there's a carbohydrate called the H-type 1 antigen, which are present on epithelial cells. And if you have it, you are secretor positive and you're susceptible to infection. If you don't have it, you're secretor negative and you're resistant to infection. That's the model that we think of. However, different norovirus strains behave very differently as well. So just to illustrate how this occurs, here is somebody who's secretor positive and is ingesting norovirus. Now, after they ingest it, their epithelial cells will have this H-type 1 carbohydrate. And the virus can bind, internalize, and once they're internalized, replicate, and reproduce, it can lead to infection, and it can also lead to disease afterwards. Now, in the case of a secretor positive, then they're more likely to become infected and diseased. Now, in contrast, when you have a secretor negative individual that ingests norovirus through food or water, etc., their epithelial cells don't have the carbohydrate, so the virus cannot bind. There is no infection, and therefore there is also no disease. Now, in contrast, when you have a norovirus positive individual, again, they will ingest it. Their epithelial cells will have the H type 1, but you also have now the immune system that fights antibodies and cellular immunity that can protect you from the virus, and therefore you do not have infection, and also you do not have disease as well. So very broadly, that is the mechanism as we understand it. And recently, we discovered a mouse model that we can start using and a cell culture model. So we're starting to learn more and more about the immunology behind norovirus as well. So some of the work that we have also done is trying to understand how long is immunity. So similar to some of the work that the previous presenters have discussed, norovirus has short-term immunity. So in the clinical challenge studies that we have done, we've seen that the immunity lasts about from 6 months to 2 years. But in some of our epi modeling studies, it can last between 4 and 8 years. We're also in the process of testing a lot of different norovirus vaccines, some intramuscular, some oral, some in a pill form as well. And they work about 40 to 60% with the same strain of norovirus. So there's promise ahead, but we're still not there yet in terms of a full vaccine candidate. So to answer the final questions, no, some people are resistant to norovirus, and there are different strain differences. So some people have resistant to some strains of norovirus, other people are resistant to other strains of norovirus, so this will vary. And immunity may last up to 8 years, but it could also be as short as 6 months. So in closing, I wanted to also share that WHO has started to calculate the burden at a global level. And they have determined that norovirus is the #1 cause of foodborne illness in the whole world, and the 5th cause of deaths due to food and dialysis as well. And in the world, they estimate that there's about 700 million cases and about 200,000 deaths due to norovirus, of course, affecting children under 5. So the last slide I wanted to ask you in terms of participation is whether you would like to participate in a human challenge study. And how much would I have to give to you in order for you to participate? So would you do it for free for the love of science? Would you do it for $500 to pay for your very expensive wedding photographer? Would you do it for $1,000 because you need a vacation after all these exams at FASE and need to go to Cancun? Or no amount of money is enough for me. So let me just get a show of hands. How many would do it for the love of science for free? Okay. How many would do it for $500? 500. Okay. So maybe like 8, 9 of you. How many would do it for $1,000? Okay. So a couple more of you. How many would not do it for any amount of money? Okay. So 10 of you. So for those of you who do it for some money, then we benefit and we have learned a lot from you. So thank you to all of you who do decide to volunteer. We give our volunteers about $800. So between these two, in order to participate in the study, $500 to be in the hospital, $300 to come back for their outpatient visits. So in closing, I wanted to say thank you very much for your attention and any questions if you have them as well.
Oh, wow. So, well, do you have questions? All right. So, do you have the microphone? This one can be this one. Okay.
I guess I have two. One, do you make sure that your volunteers are secretor positive? Yeah.
Yes. So
Hold on, we need a
So the question was, do you test for susceptibility? So remember that some strains work with susceptibility and some strains don't. We use a strain that does depend on the secretor susceptibility, and all our volunteers, we do test them via saliva test. So we have them spit, and then we do an ELISA to see if they have the carbohydrate before we put them in our study.
And you showed the CDC slide that said something like it's estimated that we have 5 infections per year per person.
In a lifetime.
Oh, in a
5
lifetime. Okay. Okay.
Great talk. I have a couple of questions. So, so those shedding studies, how long did you go out for? Like you said, up to 2 months. Did you just look at 2 months, or did you look at 3 and 4 and 5 and 6? And
So our study ended at about 35 days.
okay.
However, if the person still was positive, and we had a couple of people that were still positive,
Mhm.
we kept having them come back week after week until they stopped being positive.
Uh-huh.
And then we said, okay, now you're safe and it's fine. And every time they came back positive, we said, you have to wash your hands, you have to be very careful,
Mhm.
etc. So for those people, we follow until about 60 days.
Okay. And so, okay. And everybody was negative at 60 days.
Yes.
Okay. Is there any cross protection between strains at all, or it's all very strain specific? So Norwalk, if you get Norwalk, you can only get it once in your life and you're protected for life?
That's a great question. A lot of people are studying that. There is a thought that generally within genogroup, there's cross protection.
Mhm.
Across genogroups, there's less protection there. So with it, if you get infected with a G2.1 and then a G2.4, you probably are going to be protected within a short span, maybe 6 months, etc. And across genogroups, maybe, but less degree.
Mhm. Okay. And so that G2 and G4, those would be like the same, that would be like Norwalk types or something, or,
Yes.
okay, but across Norwalk versus that whatever snow one,
Snow Mountain.
that one, they're not going to protect ever.
Less.
Less
It will
so,
protect, but
for a small
less.
amount of time and
Yes.
less. Okay.
Less.
So as far as
for people.
vaccines go, you're going to have multiple viruses within that vaccine to give protection.
Exactly. For norovirus, we're thinking there's going to be like the cold, like for the flu vaccine, that every year we're going to have to do a cocktail of different kinds of noroviruses that we give as a vaccine. And each year is going to be different.
Okay.
All the way in the back.
All right, so that was a great talk, and I was wondering if there are other signs or symptoms of noroviruses. You talked about heavy abdominal pain, but I was wondering if body aches and fever are also relevant to be taken into consideration.
Yeah, so the question is about symptoms, and we haven't, and it's true, we have all the different manifestations of symptoms, and it seems that different strains create different symptoms. So some are more the vomiting, some are more the diarrhea, some are more both. So you're vomiting and having diarrhea at the same time, which is not a lot of fun. Others are more aches and pains.
I bet.
And so it seems to vary depending on the strain, but generally, most people have that spectrum of illnesses, some more and some less. And the relationship between amount of virus and symptoms is not clear. We think that the symptoms are the immune response to trying to fight the virus, not so much the virus causing damage in the person.
Right. Thank you.
I don't know if you mentioned, but so what is the source mainly of these, other than stool, but and shellfish? Are there other sources of food that we should consider avoiding, or obviously washing our hands at all times? But what are there other sources?
Sure. So as I showed, there were like different genogroups. Some are human, some are animal. But the genogroups for humans only affect humans. So it's mostly an anthroponic disease. And those for animal only affect those animals specifically. Now, within the humans, many things have norovirus. So carpets, surfaces, water, foods. I study a lot of, so for example, on cruise ships, there was episodes where people vomit on the carpet, and then 2 weeks later, people were stepping on the carpet, aerosols would come up, they would ingest it, and they would get sick, and then a new outbreak on the new cruise ship that somebody was on vacation, having a great time, but then they had diarrhea and vomiting. But I do a lot of work on fruits and vegetables, and we're doing a lot of work on the US-Mexico border to understand how much norovirus there is. Some very preliminary work is that about 25% of the fruits and vegetables that we've tested had norovirus, RNA, but we don't know if that's going to cause disease in people. So many things have norovirus, but we don't know if it's dead virus that won't cause disease in people, and we just have a lot of RNA just lying around because it's very resistant in general. So a lot of questions.
Okay, all right. So I have a last question. So how did you get your RB approved at that? So I'm curious to see you battle with them. So a lot of back and forth. So RB, for the ones that doesn't know that, is our Comitê de Ética. So my question is how he get the approval from the Comitê de Ética for that.
So that's a great question. So there's many different layers. All our studies have to have human ethics approval. And we have been doing this for quite some time, since the 1970s. And we have been using the same strain of inoculum. And our group was one of the groups that has been doing it for the longest. So we did have to have many protections in place. We had to have a data safety monitoring board, just like any clinical trial. And we had to also stop the trial at different stages if our volunteers didn't get sick, and do a lot of reporting to IRB. Since we started to get funding by NIH, now we had to get an IND, investigational new drug approval. So we decided to treat norovirus like a drug. And so we have gotten investigational new drug approval for norovirus, and we have different inocula that are now with IND approvals that now different companies want to use in their studies. And it's very expensive to buy and do our clinical studies, especially for vaccines. So many approvals at this stage.
Okay, thanks so much, Juan. And we have now a break, all right? So we have some snacks there, just a coffee. And so 10 minutes and we'll be back and switch completely the field and we will talk about neurosurgery, all right? All right. So let's do 10 minutes, all right? And we'll be back just to not finish too late, all right? Almost there. Just for a few minutes. Hello, let's go. All right. Okay, so we have we have our final talk tonight, and this is a very exciting opportunity here because it's not a usual topic that we discuss in global health or at least in public health meetings. But when Dr. Alexei told me that he would be coming to Brazil with Desiree, I immediately thought about would be beneficial to hear for someone that is involved in the field what are the needs in the perception or the home perception about the needs on neurosurgery for the global health or public health. So we'll have then the Dr. Alexei Lavery from Kaiser Permanente Medical from the Redwood Medical Center, and he'll be talking about global neurosurgery, the unmet need. So thanks so much, and please welcome Dr. Lavery. Thanks, my friend. So here is the pointer.
Well, thank you very much for everyone staying this late to listen to this. It's really hard to follow such amazing scientists here because I'm definitely the odd man out. I'm a clinician, and I mainly practice neurosurgery at Kaiser Permanente in Redwood City, which I'm going to talk a little bit about Kaiser because I was asked to do that partly. And so just a little overview of what we're going to be doing is I'll talk a little bit about what Kaiser is, what that system is, and what I'm working in, and then I'll talk about what we have in terms of neurosurgery there, and then I'm going to talk about the global surgery, basically the Lancet Commission on Global Surgery, which is a very important subject. It's kind of like the neglected stepchild. If you imagine tropical diseases are neglected, then this is the neglected stepchild of global health, and it's something of a surgical spring in 2015, and so we'll talk a little bit about that, and then I'll talk about the state of global neurosurgery, which is still kind of in its infancy, and so let's get started here. So just a little bit of history of what Kaiser is created by this guy, Henry Kaiser, who was a physician who realized that the workers didn't have good health care and had them pay in to the system, paying 10 to 15 cents per paycheck, which we created insurance, which is one of the first kind of people to create what's like an HMO, basically. And that was the first kind of, it was just an all-inclusive system where you paid into and you got all your care there. And so you wouldn't be slapped with a huge bill if you got sick. And he noticed all these people that were doing construction were getting hurt all the time. And then they would be out without pay and things like that. And so he made a really a robust system that now is thriving. And this is kind of what it's morphed into, which is a three-tier system. There's the hospital system, there's the health plan, which is the insurance, and then there's the physicians. And so that they provide everything for the care of the patient, so including the pharmacy services, the labs, everything. So they're able to contain the cost of the healthcare for the patients. And they came up with this pretty fancy Thrive campaign, and they're pretty much focusing on a lot of preventative things because that's important to try and reduce the cost if they can prevent disease before it happens. And so this is where I'm practicing in Northern California, where we have 4.2 million patients that we're covering. But you can see that it is kind of spreading across the United States, where we have 12.2 members entirely over the system. So just a quick overview, we have 39 hospitals and 690 offices with 22,000 physicians and 60,000 nurses, just a major employer basically in healthcare. And it's also, again, just by the numbers, Northern California and Southern California are the major players for patients. And it's a pretty large operating budget with $72 billion right now. So, and I don't see that money, by the way. And just to quickly go through some of the things that we've been able to do is reduce cardiovascular disease by 48% by different programs that we're able to do, reduce stroke and death, able to reduce smoking rates in our by down to 7.2 or 7.5% in our patients, where the national average is 20%. Same thing with getting people in to have TPA quickly. Reduce that time to less than 30 minutes when they get to the ER. And that's really saving lives from stroke. That's one of the things that our facility does, as well as working people up faster for things like lung nodules and seeing specialists quicker, so improving the access to patients. And so just a little bit of, sorry about talking to the mic here, but just to kind of like toot the horn, it's like, there's all these different grading scales. And so, we've got number 3 in the nation for this one, and, the 5-star rating, which everyone really wants to get for Medicare. And same thing for, these other, like, people are satisfied with the care, basically. And so it's working, and it's a pretty good place to work because of that. So this is where I work, is Redwood City, and these are all the coverage areas that we have in Northern California. And so when I'm on call, I may get called from any one of these regions for something, has to do with an emergency, which I'm trying to manage, either keeping the patient there or bringing them to Redwood City. And so that's sometimes of a bed crunch in terms of how much beds we have. So this is our center, which is 150 beds. It's a relatively small hospital, but we do have 20 neuro ICUs, and we have epilepsy monitoring. We have 13 neurosurgeons there, so it's pretty much centered for most of Northern California, covering the neurosurgery. We have 4 intensivists, and we have a stroke center certification with 2 interventionalists there, with 3 dedicated neurosurgery OR suites. So just kind of overview of what we're doing there. And so working in this system, it's electronic medical records for all the patients. So it pretty much can open the chart for any patient within Northern California and see what has been done for them from my home, even from my cell phone. So that is a technology that they've invested over $1 billion in, just having this kind of electronic medical records, which is pretty much across the United States is becoming a standard. And that gives me access as well to all the MRI scans, the CT scans, and films of a patient. So if I get called, I can pull that up, even on my cell phone as well. it is a metric-driven system in that it's big data, right? So it's driving the access. They're telling us how quickly we have to see patients. We have to see patients within 3 days if there's a consult. They're trying to reduce wait time. They're trying to get, there's an agenda basically because they have so much data with this. But the aim is to keep the cost down while maintaining a high quality of care. And but even though you know, neurosurgeons can have fun, and so this is sometimes what we do in the OR. I'm not always going to be like, you know, too stiff, but so this is what I was asked to talk about initially, was more about global neurosurgery, and this is what kind of starts us off, is that this with the Lancet Commission on Global Surgery, they in 2015 estimated that there was 5 billion people with lack of access to safe, affordable surgery and anesthetic services. And that meant was predominantly in low to middle income countries, where 9 out of 10 people had no access to basic surgical care. And so that meant that about 18 million people were dying each year due to the lack of surgical care, which is 3 times of the death of HIV, malaria, and TB combined. So they're saying that this is really a very serious issue. And so the key messages, again, was that 5 billion lack access to safe, affordable surgical care, and timely access is essential to reduce this death and disability from surgical conditions. And neurosurgery is one of those, the main causes of death when it comes to head trauma, for instance. And there's 4 dimensions: are timeliness, surgical capacity, safety, and affordability for the patient. So the 2030 target from them is to get 80% coverage for these essential services. And this is an example of where the proportion of people that have without access to safe, affordable surgery and anesthesia. And you can see that it's predominantly in sub-Saharan Africa and Southeast Asia, but you know, all the way up into obviously some of these areas where they do have a good amount of physicians. But Brazil is doing pretty good here. And then this is the distribution of surgeons, anesthesiologists, and obstetricians per 100,000. And some of these countries do not even have data to tell us how many physicians they have there. But this, again, is really lacking in their distribution. But you can see that some of them have way more than they need, probably, up here. So the second key message from this Lancet survey was that there's 143 million additional procedures that are needed each year to save lives and prevent disability, and that these are easily treatable. These are things like fractures that don't get repaired, bowel obstructions, hernias, and this is really something that becomes a fatality if it's not treated. So the target for 2030 would be to get at least 5,000 procedures per 100,000 population, and that's kind of the estimate of what we need for most of these countries. And so this is the annual unmet surgical need by region, and you can see again that the major ones are kind of East Asia, Eastern Sub-Saharan Africa, South Asia, and then Western Sub-Saharan Africa, and that's where the 143 million came into. So the third key message was just that these are catastrophic health expenditures for people that do seek care. So 33 million are really out of luck once they do get care. And so this is defined as medical payments for their surgical care that exceeds 10% of their income or 40% of their income after their basic needs of food and shelter are met. And that means a quarter of people who have a surgical procedure will have a financial catastrophe for seeking that care. And so the target is to get 100% protection against this catastrophic expenditure. And that's going to be very difficult, obviously, but we need to be partnering with banks and things like that to really, and insurance to help people. So the fourth message is just that investment in this is affordable because it saves lives and then it promotes economic growth. And it would take about an annual increase of 9% per year to reach that 5,000 procedures per 100,000 at this rate. And this is an achievable goal. This has been achieved in Mongolia already. And so I think that there is hope that we can get to there by 2030. The cost is about 420 billion, and these are all estimates, but it's felt that this will actually result in inaction would result in 12.3 trillion loss, or basically 2% annual GDP loss. So it actually is going to save money, even though you're spending 420 billion. And this is just a cut to show that a chart to show that loss in the GDP and where it's coming from, basically. And the majority of it is from injury and neoplasm, but all of these are things that are treatable, and and that adds up over time. I'm sorry. The last key message is that really surgery is indispensable to the care of the patient. So it's a critical component. And so throughout all disease subcategories, surgery is essential, as it's from birth to death, and from prevention to palliation for patients. And this burden of surgical care is increasing in all of these areas. So in total number in relation to the other health gains that we've already been seeing in the infectious disease categories. And so this is just the core indicators of whether or not there's safe and affordable care to things. And this access to timely essential surgery, again, we want to get 80% coverage by 2030. Specialist surgical, we want to have the surgical workforce. We'd like to have 100% of countries with at least 20 surgical or anesthetic obstetric physicians per 100,000 by 2030. And we looked at that chart where there's plenty of countries that are nowhere near that at this point. Again, the surgical volume, getting it up to that 5,000 per 100,000, and checking mortality rates, which is not even being tracked in many of these countries at this point. But trying to get 100% of countries tracking their perioperative mortality rate by 2030. We would hope to prevent people from being impoverished by the payments for these surgical procedures to 100% by 2030, and prevent them from having catastrophic expenditures. So in May of 2015, the WHO actually passed unanimously this resolution, which is to say that surgery is a component of universal health coverage. And this is really providing a lot of impetus for people to start working on providing more global surgery. That's where this kind of comes in play, that global neurosurgery is defined as an area of study, research, practice, and advocacy that plays priority on improving the health and outcomes of achieving health and equality for all people worldwide. And this is kind of one of the first articles to talk about global neurosurgery. The lack of neurosurgery is really profound, basically. In most developed areas, you expect this ratio of 1 to 80,000 population. But in many areas of the world, it's only 1 neurosurgeon to 10 million people. And that essentially means that the patients never would see a neurosurgeon, except for the very fortunate few that may be able to pay, which actually adds another layer to this, in that people that are able to pay are going to have a disproportionate amount of the care that's given by these neurosurgeons. Oops. So the estimate for neurosurgical procedures is about 5 million cases per year that should be done. These are essential cases. This is not degenerative spine cases. These are the hematomas and things like that, hydrocephalus. So mainly traumatic brain injury, strokes, tumors, hydrocephalus, and epilepsy are the majority of these. And that equals 23,000 neurosurgeons needed worldwide to alleviate this deficit. This is neurosurgeons per capita worldwide, and you can see the areas where really needed are mainly, again, Africa, sub-Saharan Africa, and some of the areas up in Central America, and then Southeast Asia as well. Majority of these cases. But you can see that there's some outliers, like Japan has a ton of neurosurgeons. There's more neurosurgeons in Japan than all of the United States. So here that's just demonstrated that Japan, way up here on the top here, more neurosurgeons than anywhere else. And then Brazil is somewhere right here, and US is here. But you can see there's places that have hardly any at all. And some of these, I'm not sure, some of these high income ones, they didn't really say what those are, but it's kind of interesting to see that there are some countries that have very few neurosurgeons that do have high income. So what's being done about this? At this point, this is an entity, FIENS, Foundation for International Education, which is really what's needed is to educate more neurosurgeons. And it's been around since 1969. I actually did go to Thailand through this institute, and they currently have 27 sites, and these are some of the major projects they have going on right now. And as well as the World Federation of Neurologic Societies, and they have 21 postgraduate trainings, and basically trying to really train local neurosurgeons that are going to stay there and do the work that needs to be done. Because what happens is you go and you train these neurosurgeons, a lot of them end up going to the places that have the better facilities, and they concentrate into the larger cities. And so we need really to try and decentralize that care so that more of these cases are done where they're needed. And that means kind of giving up doing some of the more complicated cases to really get the basic stuff done. But both these entities are working to elevate these local systems by providing discounted equipment and training to the facilities. There are a number of challenges, obviously, partly because geographic isolation, bureaucratic resistance, that political instability in a lot of these countries, and that the socioeconomic changes are constantly going on, as well as high rates of poverty and illiteracy. And some of these have rapid growing populations. Some of the other challenges, obviously, are having the compassion and actually when you come to try to do the training, that you don't have this kind of an attitude here, as you see on this mug. But other challenges are that neurosurgery has been relinquished to non-neurosurgeons, and I have two examples to follow. But also, there's been an underrepresentation on this global level, meaning that the WHO has this World Health Assembly, and it wasn't until 2017 that there was one observer that actually came to be at the table. But there have been some people kind of seeing this and starting to spearhead this with 20 active participants in 2018. And so there is some hope that there's going to be some leadership from neurosurgery. But one example would be that in this third edition of the Disease Control Priorities, which was Essential Surgeries, which has 7 authors, 3 were trauma surgeons and 4 were orthopedic surgeons. And they acknowledge that the head trauma was the leading cause of death from injuries in the developing world, but there's only a single page dedicated to head, neck, face, and spine. So obviously there's just no representation for that. And then secondly, WHO has a surgical care at the district hospital, which is a guide, 514-page surgical reference. And there's one neurosurgical procedure in this, and it's listed in the orthopedic section. And the only procedure is a cranial burr hole, which I read through, which is actually partly correct. So it's kind of, I don't think any of you would be able to follow that and actually do the procedure. So, I mean, really, it does take a brain surgeon to do some of these procedures. In conclusion, is that we do need a global health strategy that's going to address the unmet need, because it's a moral health and financial necessity for patients. And we need increased representation of all subspecialties on a global level, because surgical care is affordable. It's an essential component of patient care, and we need some more global collaborative efforts to solve these challenges. So these are some of the resources I had, and I want to thank you for having me speak, and thank you for staying.
Thanks so much, Alex. So questions, comments? All right, we have one. Come back here.
Hey, good night.
Well, here in Brazil, we have lots of neurosurgeons in big capitals like Belo and São Paulo. And if someone in the countryside has to do a neurosurgery, this person have to travel to here and operate. And I would like to know if in Africa, like I said, there are no neurosurgeons, but they do not want to go there, or there are not big centers like hospitals to get these people.
I think it's both. So it's hard to find any surgical care in some of these places. But people that do, it's hard to get people that are going to get trained. And if they do get trained, then they go to these bigger centers where that's where they're going to be trained in the first place. So it's trying to actually first create surgical centers so that they can actually perform surgeries. Obviously, you don't want to perform surgery and have infections. And that doesn't really help anyone. And so it's a whole team effort. It's not just having a neurosurgeon. It's having ICU, having nurses, having sterility, having people that can give you the instrument that you need. So that's part of the challenge, is you have to really create the whole system, and it's lacking right now.
Thank you.
If a medical student here would like to do more in this area, like your talk really excited them, what would be a good next step for a medical student here?
Well, looking at the fiends, they have funds to send medical students to any of those sites. They have 27 sites. If you go on their website, there's a number of people that are working through that. But they're looking for people to help train, really, as opposed to being observers. So I think getting involved with probably working with the local neurosurgeons here to try and create like a mission to go there, for instance, to one of those sites. That would be a good place to start.
Well, just one comment. I'm part of the directors of a big hospital in Belo, Hospital da Baleia, and we usually had a big neurosurgical surgery unit, and we are going down now just because we have several issues in terms of the payment from the healthcare system here in Brazil. Because the procedure, if we are thinking about money, about payment, the procedure is good in terms of it's self-sustainable, or you pay and receive a good money for that, or you can pay everything and the hospital is happy. But the follow-up, especially in public health, is very weak. So the patients go to a nurse, to a clinical ward, and go there and stay there for a long time. And so these usually create a lot of problems in the balance of the patients at the end. So how do you feel about this? Kaiser Permanente is a whole private sector, right? So, but this is a difficult situation to handle, especially in SUS, the healthcare system in Brazil. So this is a limitation that we have seen. Many hospitals are closing the neurosurgery, just finishing or going down because there is a problem with the money replace or the payment, the payback. And so that's an issue that we are facing here right now. I don't know, it's just a comment because this is exactly the situation we are seeing in one of the most important hospitals for neurosurgery in Belo, that's Hospital da Baleia. We are just shutting down the neurosurgery. Maybe tomorrow we can talk about this. We'll be visiting there, but just a comment.
I mean, I would comment that we've regionalized neurosurgery in Kaiser. So we have 2 regional centers. So people are traveling quite a ways to get there. But there are much more trauma centers with small amounts of neurosurgeons that are not Kaiser patients, not Kaiser neurosurgeons. So we have the infrastructure in California to provide that care on an emergency basis. So specialty care like tumors or even degenerative spine, that really should be done at a large center where they have a specialty that they can really have low infection rates and really provide the best quality of care. Yeah.
All right. Okay, we're done for today. Thanks so much, Dr. Alex. So tomorrow we have our final day, okay? We'll be starting 7:30, Okay, so if you have an open agenda for tomorrow night, so you are welcome to join us. Okay, thanks so much. Have a great night.